टेस्ट निकल गया, आप क्या करेंगे? नाउ व्हाट डू यू डू एंड व्हाई आर वी डूइंग दिस? भाई सी बताओ।
जो मटेरियल है उसका स्ट्रेस और स्ट्रेन पता चल रहा है, सो
कैसे पता चल रहा है?
जो हम कैलकुलेट कर रहे
But how we will get the nodal values? How do we get? So we took one structure and then we made some elements here. Okay? Then we take one element out and then we define our epsilon and eta. Then we find out the ni's. From ni's, and what are ni's? Ni's are functions of epsilon and eta, right? From that we describe u as a variable, okay? Ni, ui, and then all the story goes on from here. We have u, and then we calculate strain from this, right? So strain is bu. What is b? Well, b is something. From strain you can calculate stress, right? All the things are there. How do we get the ui? नोडल वैल्यू तो नहीं पता है, वो कैसे पता चल? कहानी खत्म। हम क्या कर रहे हैं, क्यों कर रहे हैं? विपिन, क्यों कर रहे हैं मॉडलिंग एंड सिमुलेशन? Why are we doing this? So one idea was that if you have complicated geometry, a complicated function, if you have a polynomial of order n and n is more than 5, then in that case finding the root of that polynomial is not that simple, right? So if you have square, circle and cylinder and things like that, then you can do geometrical calculation and be Archimedes and calculate the area. Also a little complicated things you can do. But what about a gear? When you have a gear in contact with a shaft, then what will you do? Theoretical analysis. How will you find out contact forces? How will you find out frictional forces? How will you find out the temperature which is increasing in the lubricant? So things become very complicated. Okay? In order to solve that, how do we proceed? So we take this simple idea that any complicated shape can be defined as a combination of very simple shapes. Okay? So a circle is a line and a sphere is a linear brick or a cuboid. So all the materials, whatever you study in metallurgy, you put them in unit cells, right? So at some level, even materials are showing that they are made up of very simple shapes. Okay? And very complicated things are happening in those simple shapes. Okay? So what are we trying to do? We are trying to find out a numerical algorithm, a numerical technique by which we can calculate complicated things by dividing into small pieces where simple calculation can be done. And if we increase these numbers of simple calculations, we can also approximate a very complicated function. Do you follow? Okay? So we will do all those things. So u and epsilon and stress, and from stress we will calculate a stiffness matrix, and then we will do what? How do we find out the ui's? That's the question. How do we do that? How do we really solve the equation? Do you have any idea, any guess? Do you understand the question? देखो कम क्वेश्चन समझ में आ रहा है? क्या बता है क्वेश्चन सब क्या?
एट द एंड हमें यूआई पता करने हैं, वो कैसे करेंगे?
यस, कैसे करेंगे? analytical solution and numerical solution. क्या difference है? क्या difference तुम बताओ? तुमको तो marks मिला कल की class में. Analytical, numerical solution में क्या difference है? Can you give me an example? Can you give me an example of analytical and numerical equation used for one thing?
सर इसमें हम कोऑर्डिनेट्स वन कंसीडर कर रहे हैं उसके.
Coordinates?
वन कंसीडर कर रहे हैं.
One. हाँ हाँ.
तो वो डिफरेंस बनता है.
नहीं इसको भूल जाओ. कोई चीज डिफाइन, कोई फिजिकल इवेंट डिफाइन करने का एक एनालिटिकल सॉल्यूशन हो सकता है, एक न्यूमेरिकल सॉल्यूशन हो सकता है, एक एक्सपेरिमेंटल सॉल्यूशन हो सकता है. डू यू अंडरस्टैंड द डिफरेंस बिटवीन दीज थ्री?
To find resistance, we use analytical. We check like length is factor and all this. With the factors, we just pick. Without any perfect calculations, we found out resistance maybe with length and area.
बोलो तुम बताओ एनालिटिकल सॉल्यूशन क्या होता है किसी प्रॉब्लम का? एनालिटिकल सॉल्यूशन क्या होता है?
सर एनालिटिकल में मतलब assumptions होती हैं.
assumption तो सब में होती हैं.
न्यूमेरिकल में तो
हाँ.
डिफाइंड हम कुछ कैलकुलेट करते हैं.
क्या कैलकुलेट करना है?
मतलब लाइक प्रॉपर वैल्यूज के साथ कुछ कैलकुलेट करेंगे.
एनालिटिकल बिहेवियर में
एनालिटिकल सॉल्यूशन है ये ऑन ही है, इसको लगाने से इसको ये प्रेस करना पड़ता है पर अभी नहीं होगा. So for example, you have a problem, you can define the solution. So let us say force on a body. You can हो गया, thank you. क्या चीज क्या गड़बड़ था? पर हुआ क्या था?
वो डिस्प्ले की प्रॉब्लम थी. एक डिस्प्ले लैपटॉप.
अच्छा वहाँ से ना. Thank you. Okay. So for example, force on a body you can define in terms of an equation. Okay. So something like this. Force on a body is a function of coordinate x. Okay. And this you have found from some theory. Okay. So that is an analytical solution. And for this you know the value. By putting the value of x you can get the value. Numerical solution is you don't know the function. You really don't know the function. You don't know how the forces are going to be with the change in coordinate. You are approximating it. Okay? So like you don't know the roots of an equation, you are trying to approximate it and then try to minimize the error. That's what you do in Newton-Raphson, bisection and all those methods, right? And the third way would be experimental. Do the experiment. So put the load cells at different coordinate values and find out the value which is shown in the load cell in the form of force, and then you get it. Okay? So one of the algorithm is finite element analysis, which is also numerical. We don't know the solution, we are trying to approximate it. But it's not that we don't know anything. We have some ideas which are called, we have some information. Those informations are called boundary conditions. Okay? So, for instance, if this was that ring which we discussed, which is under its own load, then we know that this is, this is not a sphere, so it's a ring. So what do we know? We know that there is a weight which is acting. So you can define it as a rigid body, then there is no, not much to do here. But then if it is not a rigid body, then weight has to be distributed everywhere in all the points. Apart from that, what else do you know? You know that this ring is probably not rotating, right? So the torque is 0. Okay? Then you know that there are some frictional forces. So these are the information which you know. Right? Using these informations, we can, so for example, in the cantilever problem, what are our known information? Our known information was we have a force applied on this point where x is equal to LT, and we knew that at x is equal to 0, u is 0. These were the known information. So these were the boundary conditions. And from these information, we are going to get all those nodal values by doing what? So the idea which is used in finite element is minimization of potential energy. Okay? In most of the cases, as long as you don't have velocity problem, we will be using minimization of potential energy. Okay, what does that mean? Any body will have some potential energy, and any body will try to minimize its potential energy. So we will also do that, and whatever value comes in order to minimize the potential energy, that will be our solution. Okay, so potential energy can be written as strain energy, thermal energy, and the work done on the system. Right? इसके अलावा जो भी एनर्जी है सब ऐड कर लो. Okay? So strain energy we can write it as right, and then we do the integration in whole body. If we are taking small elements and we are calculating strain energy in each element, then we will have to integrate over whole body. That will be my total strain energy. If there is some thermal strain, then you do that. If it is not there, there is no need of it. Okay? And then whatever work is done, that you can write as displacement into force. Okay? If it is one dimensional, write dx. If it is two dimensional, write dx dy. Do the double integration. If it is volume, do the triple integration, and that should be it. Do you follow what I am saying? Okay? So this is potential energy. And then you have assumed a polynomial in the form of shape function, in the form of unknown. Okay? And then you have to minimize that by differentiating it with all those unknowns you have used, put them equal to 0, and then you get the values of those AIs. Okay? So you remember, we can assume displacement to be a function of A0 plus A1x plus A2x squared and so on. Right? So if I take only first two terms, that will be my linear shape function. If I take three terms, quadratic shape function. In some cases, some things are known. For example, at this point in the cantilever, I know that at x is equal to 0, u is equal to 0, right? So if I take only two terms and take x is equal to 0, A0 must be 0. So I can remove A0. I don't really need to solve it. Okay? So I can simply take a function u is equal to A1x and apply those in this and solve it by doing del pi p del A1 is equal to 0, and then I find out what should be the value of A1. Okay? So for example, let us say that u is equal to A1x. Okay? And let us take a one-dimensional problem. So in that case, my strain energy will be integration of, so that will be stress transpose into strain dx, right? can write as, so I can write it as E into epsilon, so that will become epsilon square dx, and I can put half out, right? And let us say there is a distributed force, so that distributed force I write as this into coordinate value. It's a distributed force on the on a bar element or a one-dimensional element. Okay. So what will be my second term? My second term will be force into displacement d. Right? That is the work done on the system. This is the strain energy in the system. Okay. So this became elastic modulus strain square dx minus ucx dx, and let us integrate for the length of the element. Okay. So strain I can write as del u by del x. I don't have all those shear and all those things because it's one-dimensional element. So it will just be del u by del x. So then here I will have E into this squared dx minus whatever. Okay. So then what will I have? Half into E, and then del u by del x will be A1. Right? Del u by del x will be A1, right? So A1 square minus, so I have ucx dx, right? So u is A1x, and then I have x dx, right? So it becomes x square dx integration, and I also have integration here, no? So what is that? Dx. Okay.
So C.
What happened?
C.
C is needed, no? So C, and there I have A1 and dx, that's it, right? So dx integration will be x, will be LT, right? So E A1 square LT by 2 minus, and this will be how much? X cube by 3. So LT cube by 3, right? So this is pi p, and just do the derivative of this with respect to A1, then I will have E A1 LT minus C LT cube by 3. So I will get the value of A1 from this. When I have the value of A1, I know the value of U. Right? So this is a very simple example of what we are trying to do. Okay? So let us come back to what we were doing. Okay? And I want, have you found out the values of N2, N3 and N4 and all those things? निकाला है क्या किसी ने? नहीं निकाला, क्यों? तुम लोगों को बोला था निकालने के लिए. चलो N2, N3, N4 का वैल्यू निकालो. we have symbols of epsilon and eta, right? How do I write epsilon? I'll write n, okay? And eta I'll write n, okay? Then what will be my n1 for instance? Oh, n1 will be also a symbol, no? But can I define n1 as a function of symbol? So that will be 1 by 4 into, बोलो n1 का क्या value? Epsilon minus 1 or 1 minus epsilon? 1 minus epsilon into
eta
ये तो symbol नहीं आ रहा है, ये symbol क्यों नहीं आ रहा है? Is it a symbol? Yeah. Okay. So n1 हो गया. Now n2 is how much? Tell what is the value of n2? तुम लोगों ने निकाला नहीं इसको? If you do less work, then I will give you more work. Or complicated होता रहेगा. If you make it simple, then it will be. If you keep on progressing with what we are doing, then it will be good for you also. Okay?
And 2 eta plus 1 and eta plus 1 epsilon plus 1 by 4.
रुक जाओ. हाँ, अभी बोलो. n2 is
Eta plus 1
1 plus eta,
epsilon plus 1.
1 plus eta, 1 plus epsilon.
हाँ भाई.
That is n2. Okay?
By 4.
By 4 तो हो गया. हाँ? Minus है क्या?
पहला वाला epsilon 1 minus minus 1 होगा और 1 minus minus 1 होगा तो वो 2
नीचे वाला epsilon 1 minus epsilon 2.
n2 बता रहा हूँ.
हाँ ठीक है. n3. What is n3? What is the value of n3?